Well, hello, everybody.
Hi.
It's my pleasure and honor to introduce tonight's speaker, Dr. Ann Bull. Dr. Bull is the Chief of Environmental Sciences for the Pacific region of the Bureau of Ocean Energy Management, also known as BOEM. She earned her bachelor's degree in both biochemistry and biology from University of California, San Diego, and went on to earn a master's and a PhD from Louisiana State University, and completed her graduate fieldwork at the Marine Biological Laboratory Woods Hole in Massachusetts. Her postdoctoral work at Johns Hopkins University focused on the health of fish populations and their responses to changes in the environment. Dr. Bull's current research interests center on the ecological influence and effects on both a local and regional scale of offshore energy installations and artificial reefs. She is presently a member of the Board of Directors of the Southern California Academy of Sciences, where I know her, and we're on the board together, and is also a technical advisor for Sea Grant. The title of tonight's talk is Outlook on the Outer Continental Shelf for Offshore Energy. Please help me welcome Dr. Ann Bull.
I'm absolutely honored and delighted to be here tonight, and I'm trying to make this fun and informative, and I really appreciate the audience and taking your time away from a Friday night. I'm going to keep with the style of what Mike started, so I'm going to ask everybody, who pays taxes? Is there any, well, maybe the very young man, but anybody or their parents who pay taxes? Okay. I am a federal government scientist. I'm one of them. And I work for the Department of the Interior. Now, the Department of the Interior was started in 1849, the same year that California became a state. And in 1849, I don't think they were very concerned about the ocean. They were looking at Yellowstone, they were looking at bison, and they were looking at gold in 1849. So I worked for a little bitty agency within that big Department of the Interior. And my agency is called the Bureau of Ocean Energy Management. And I'm the chief of the environmental studies. Let me get my... But what that means is that Congress puts together the allocations, in other words, the budget, to fund departments, and they get that money to fund the departments, like the Department of the Interior, from taxpayers. So I got paid this week. I want to thank you very much. Okay, so I wanted to start this. You know, I don't want to cast a shadow, but I don't really want to stand behind this. Could stand on the other side. I wanted to start with what the heck is the Outer Continental Shelf? Well, those three words, it's a legal definition. And what it means is everything that the state doesn't have jurisdiction over out to 200 miles. So most of the states have jurisdiction out to 3 miles. So everything from 3 miles to 200 miles is legally called the Outer Continental Shelf. That is not a biology term. You will hear biologists like Julie and I talk about the shelf, the slope, the abyssal plain. No, no, no. This is a legal definition for legal purposes and for jurisdictional purposes, and it's federal land. So if you go to some monument in Utah or Oregon or Yellowstone or Yosemite, you know, that's all federal land. It belongs to all of us, actually. This is the same thing. Oh, I need to go back and point this out. Is this the... See this? This talks about the Pacific OCS region is responsible for 2 energy programs using 3 technologies on the OCS of 4 states. That's a true statement. And every time I write that, I have to take a very deep breath because this is the Pacific OCS and this is a Hawaii OCS. And in my office, I run the entire sciences program for all of that. We have 32 full-time employees and 3 unpaid interns, and that's it. And that's a lot of ground to cover with 32 people and 3 unpaid. They are really important, though, those interns. Okay, so let's see. When I talk about the BOEM Environmental Studies Program, I need to tell you a little bit about what the goals are. The program goals are that we have to get information about these offshore energy programs, which I'm getting into tonight, because we have to, by law, predict, assess, manage, monitor, mitigate, all of those words, the impacts from offshore energy production and all of those activities on the human, marine, and coastal environments for Hawaii, Washington State, Oregon State, and California. It's a very heavy responsibility that I have lots of fun doing. So I'll give you a little bit perspective on the ancient history of the studies program. It's actually been going on under different names, but the same program that I'm running since about 1973. And I just updated this slide. I always have to put a date on it because they change. See, yeah, they change. So this is as of today. We've completed about 310 research projects out in the ocean, out on the OCS, the Outer Continental Shelf, the OCS, at about $145 million. The very early records weren't kept so great, so this is probably more, but this is about the best I can do in actual numbers. And right now we have 31 ongoing ocean research projects and ocean investigations at about $22 million, and 17 of them have to do with renewable energy, and 10 with conventional energy, and research projects that cover both of them is about 6.4 million. So these are the prospective energy projects. Oil and gas, sometimes you'll see it written and call it conventional energy. It's, oil and gas, and a big oil and gas platform. This is wind turbines, so offshore wind energy, and this is a wave energy conversion device that was tested up off of Oregon for a couple of years, and it's from New Zealand. So wind and wave renewable energy and conventional energy. So I'm going to speak first to conventional energy projects, and then this is the Discovery Lecture Series, so I'm going to tell you about a bunch of great discoveries that me and my team have made. And my team's huge. Goes all over the place. Universities, private schools, not really too many kids involved, but we do outreach also. But there's actually folks who have gotten their degrees off of some of the programs that BOEM has been able to fund that are in the audience tonight, and I just want to say, isn't that great? So, what's going on with oil and gas off California? And I'm only talking about California tonight. I'm not going to talk about Hawaii. I'm not going to talk about Oregon. I thought I'd bring it home and make it local, because you have some of these platforms off your shore, right out here off of Huntington Beach. They're huge. They're important. They're off of Santa Barbara and in the Santa Barbara Channel, and they're down off of Los Angeles, where we are tonight. So there's 23 platforms in federal waters off California. There's about 7,000 in the world. Where are they? There's some off of Italy. There's some off of Croatia. There's a lot in the North Sea. There's some off the China Sea. There's some off of Africa. Most of them are located in the Gulf of Mexico, right here in the United States. You know when you go to In-N-Out Burger and you get that terrific chocolate malt, if you like chocolate like I do, get that terrific chocolate malt, and you're pulling through the straw, and you get to the bottom of the drink that you have, or the shake that you have, if you're so lucky to be able to get through an In-N-Out because the line's so long. You start making that sound with the straw when it's at the end, that sucking sound, and you start sucking in air. Well, this is oil and gas production through December of 2014 off of California. only off of California. And right down here, red is gas, natural gas, and green is oil. That's that sucking sound right there. And when you get to the bottom of the glass, you don't suck air in this case, you suck water. So the blue is the water, and this is the oil and gas. But I don't want to leave you with a message that there isn't any oil and gas left. There's plenty left. These are very old numbers. This is about 10 years old. These are the ones I could find easily. So I don't want to give you the impression there isn't a lot of oil and gas left. There is plenty left. There's a lot left. There's a lot of oil in the world. I'm really not an expert, so yeah, will we run out? Yes, but you know, there's plenty left off California. So what's on the horizon for California? That sucking sound. Remember that sucking sound? Okay. Those are from the platforms that are here. More leasing and more platforms are not on the outlook for California. Because there is a lot of oil and gas left under the ground, under the ocean. I won't say that never again will there be some kind of drilling and some kind of production off California. That would be an erroneous statement. But I would say probably within my lifetime, within our lifetimes, it's not on the horizon for us. So what is on the horizon for us? What is on the horizon is that these platforms are going to be decommissioned and removed. These platforms are really complicated under the water. They are built and overbuilt. I mean, they have to withstand earthquakes. So these things are really built. They're welded together. This is kind of a picture of a piece that's being welded down. They're welded together. They're really complicated. And here's one that's being taken out and decommissioned in the Gulf of Mexico. This is a very small one, but just give you an idea of what they look like. So these platforms underneath the water, not above the water, not the industrial city looking type part of it, but the underwater part of it, they span the water column from the seafloor up through the sea surface, kind of like an island does when you think about it. And the decommissioning and removal of these things is a really important job for those of us who are trying to look at the energy program on the Outer Continental Shelf and what it means to get this kind of entire life cycle done. So to give you a little more information, decommissioning and removing platforms. There's 3,000 active platforms in the Gulf. There's 23 in California. It's, you know, not very many compared to the Gulf. But 20% of all OCS platforms, all of them, Gulf of Mexico, California. There aren't any on the Atlantic coast. There aren't any in the Arctic. So really, it's the Gulf of Mexico and the Pacific that has platforms, but we only have 23. Well, 20% of all the platforms are over 25 years old, but 65% of the platforms off California are over 30 years old. That's that sucking sound. Our platforms, this is one of them. If you look really hard, this picture is really blown up, so if you look really hard, you'll see a pickup truck and maybe a person. This is about 1,500 feet long. This is platform Harmony. Harmony or Heritage? Okay, one of the H platforms. Harmony, the one that's the deepest. And look at how complicated it is. Look at all of the structure. This is all steel. It's all welded together. It's good for 300 or 400 years. It won't last, you know, they won't be producing that long, but these structures are really, really built really robustly. And decommissioning and the end of production is inevitable. So what happens? What usually happens when things get decommissioned and production ends? Well, of course, all the wells are plugged, and they're plugged well below the seafloor, and they're cemented for 400 feet and just a lot. All the wells are permanently plugged below the seafloor. The superstructure, which is the industrial-looking part of it, those components are taken away to shore. Sometimes they're scrapped, because they can't be recycled or reused. A lot of times they're recycled, but where is the recycling yard that's going to take this kind of massive structure with all the biofouling that lives on it? I don't think in this country that's going to happen. So 93% of the time, the superstructure is removed, taken ashore for scrapping, recycling, or reuse. The reuse, often the bits and pieces of the top part can get reused, but often not the entire structure. And the seafloor site is cleared by divers, and it's trawled 100% in a quarter-mile radius to make sure there isn't anything that's going to disrupt fishing use of the OCS. Except for a few times, 7% of the time, and only in the Gulf of Mexico, are these structures turned into artificial reefs. So now for the discoveries part. We worked for 15 years using a little two-man submarine to go under these platforms and actually do scientific transect surveys and count the fish and size the fish. And if you could hear the audio, it's what is being said in the audio is that there's so many boccaccio, which is a kind of very important rockfish that has been legally declared overfished, that you can't count them, that somebody's going to have to look at the tape and actually count those. So the person who's counting and sizing fish is actually calling out everything else but boccaccio because there's too many boccaccio. That's a vermilion rockfish in the middle. That's a lingcod in the lower right. So this picture is of a little submarine, the submarine that we used. And here's the platform, and it felt very small being in that submarine next to the platform. Although I did have a discussion with someone at the University of California, Santa Barbara, who was worried that we would hit the platform and hurt the platform. And I took a copy of this photo, say, I don't think that's what's going to happen if we hit the platform. But anyway, it was a little two-man submarine. It was called the Delta, and it was absolute workhorse, absolute workhorse. Doesn't exist anymore, but it's rated to 1,500 feet at depth. But for safety purposes, it only goes to 1,200 feet of depth. And I went in this to the bottom of that 1,500-foot platform, which actually was about 1,250 feet. And the submarine creaked and groaned, and it was a very quick transect. Let's get out of here. So this is the boat that we use. This is not any kind of a special vessel. I can't afford a big boat like Alta Sea might be able to. No? I was just hoping. Yeah, Dr. Ballard's boat. Well, this comes down all the way from Alaska. It's the Valero 4. Long time ago, it belonged to USC. So that's when it was christened, somewhere in the 20s or 30s, I think, if anybody knows the history of the Valero. So that's the boat that we use, and that was the sub that we used. So what are the discoveries that we made? One of the discoveries that we made was that rockfish and lingcod home on platforms. So you saw all the pictures of all the fish. I'm going to get to actually like how many fish are there. But one of the amazing things we found out, studying, using your taxpayers' money, thank you, studying the populations under these platforms is something that no one ever had an idea about. Never knew anything about the fact that these rockfish home. No, rockfish don't move. Well, actually they will. And lingcod. We took some fish. This is a tagged fish, and we actually operated on them and put these radio tags in their abdominal cavities and stitched them up and held them to make sure they were all going to survive. And we transplanted them to marine protected areas across the channel around Anacapa Island, where they had all of these receivers. We got to use somebody else's receivers that told us exactly the location of the fish. And we were amazed. Some of the rockfish swam back across the channel, back to the platforms. We also saw a lingcod that left the platform, went to one of the islands, stayed there for what, 48 hours, 36, 48, 72 hours, and swam back to the platform. So we discovered that they home to the platforms, and they're very faithful to their platform community. So we took about 15, 17 years worth of data, and we actually were able to publish in the proceedings of the National Academy of Science, which is extremely prestigious and a great scientific journal if they'll let you publish. We published our data on the productivity of the platforms, and there's really a lot of math involved, and I am not the math expert, but we found that when you crunch all the data, all of the thousands of hours of transect information, we found that California platforms yield 105 to 887 grams per square meter per year. That's how people want you to, that's the speak for productivity. Well, deep rocky reefs only produce 4 to 22 grams per meter squared per year. So then we put it in graph form, and these are all reefs in the Santa Barbara Channel and around the Santa Barbara Channel. A really big one is the Footprint and the Anacapa Reef, and we've got Wainimi Canyon and the 12-Mile Reef and the Piggy Bank Reef. It's a great name. And we graphed them together, and here's what we found. And this is what got published about 18 months ago, is all these data. So how is it possible that these things are so productive and that the populations are so productive, different and more productive than a natural reef? Well, there's a couple of reasons. Natural reefs, I have a colleague that at this point in time, if he was talking about natural reefs, he would take the wallet out of his pocket. Julie's seen this happen. And he puts his wallet on the floor, and he goes, okay, if I were a fish, and I had the choice between something that stuck all the way from the seafloor through the sea surface versus the chances of me finding this wallet, where the chances increased. So it has a lot to do with their shape and the fact that they traverse the water column. But perhaps even more importantly, it has to do with the fact that they are not fished. They have never been fished. There's a safety zone that surrounds these platforms, and the way that you fish for rockfish, you're going to lose your gear on one of these very complicated underwater welded structures. So, no fishing pressure. That's a big part of the story. Okay, so then we compared equivalent habitats, because rockfishes, they're boy rockfishes and girl rockfishes. They have internal fertilization just like we do, and they live birth just like we do. So we took the two overfished declared species, bocaccio and cowcod. This is really rare. Now, these pictures do come from under platforms. If I show you another picture and it's not, I'll tell you that it's not from under a platform. And we use platform gale only, so let's see if I can, platform gale's right here. It's not the most productive. We took a low productive platform just because we want to be conservative in telling the story. And we compared equivalent habitats, and we did it for larval output. And there's all kinds of ways you can figure out how much actually, they have a great education program here at the aquarium about how big a rockfish mother is and how many eggs she'll have. It's the only species, well, certainly not human, where old fat females rule. So, if you take equivalent habitat and you look at only the bottom of platform gale, and you do adult density 1, potential larval production 1, and for cowcod the same, and you go, okay, because not only have we gone in the little sub and looked at all the platforms, we also looked at all these reefs. So we have a lot of natural reef information. So looking at hectares, because that's what the scientific journals like, it's equivalent to, you have to have 55 average natural reefs to be equivalent to 1 adult boccaccio here on Gale. 72 to equal 1 potential larval production. So it's not really important what the units are, it's important the difference in the numbers. And for cow cod, 1 to 24 or 24 to 1, and 1 to 26 or 26 to 1. So what's the proposition? What's the outlook? What's the possibilities? What's the opportunity? The reefing possibility for Pacific platforms. Rigs to reefs is a term used. I don't know if you could raise your hands. I don't know how many people have heard about rigs to reefs. 1, 2, 4. Not too many folks. But, you know, here's what it is. You take a platform, you take the top off, you take anything away that could have any kind of contaminants, and you turn it into a reef, and you cut it off 85 feet below the sea surface so the boats and ships and cargo vessels can go right over it and do that. And you turn it into an artificial reef, and the state takes the deed and owns it and manages that artificial reef. And they get half the money that it would cost industry to pay for this. And the removal of 23 platforms off of California is going to cost billions of dollars because they are deep and they are huge. They get half the money. So it's an option that is going to occur in your future because I think it will occur, you know, within the next 10 years. And California law, they passed a law in 2010 that makes this an option, makes it a possibility. So what will the state and its citizens decide? That's conventional energy. Well, I guess we're going to take questions at the end, so I hope we can have some great discussions and some great questions, but I'm going to move on to the second kind of renewable energy that my agency is overseeing and that's in your future, and it's in your future today. The outlook is today. So there's our governor, Jerry Brown, last year. He decided and made law 50% electricity from renewable energy by 2030. You know how far away 2030 is? What's this, 2016? 14 years? 13 and a half years? That's not very long. That's really not very long. Solar's certainly going to help, but you can't pave the desert with mirrors. Everybody has seen this photo, I'm sure, from NASA about our electrical use. When I go home tonight, because we're going to drive home back up to Oxnard tonight, and I hit the switch, I expect my lights to come on. That's what I expect. And Mike told me tonight that actually it's a law that I get electricity. And when I flip the switch, that if the light bulb's not burned out, but I have all those energy light bulbs, LEDs or whatever they are, in my house, but I expect the lights to come on. So offshore wind is an immediate opportunity for renewable energy. And wave energy is further in the future, and I'm going to get into that a little bit. Oh, I keep forgetting. Okay, it's windy and wavy out there. I bet you any surfer or any kid or anybody who ever goes to the beach in California could have told me that. These are the maps for wind and wave energy. If it's yellow, orange, or the best would be red, it's all good. If it's green or blue, not so good. Well, okay, I want to talk about wave, because wave is really not immediate. Wave is still in the testing phases, kind of, more or less. Europe started to look into serious wave energy conversion into electricity starting in about 2007. And the very first, you'll hear these terms. You'll hear it. Maybe not a term I use, but people will call them wave farms or wind farms. I like to call them installations or arrays but you'll hear those terms. So the very first wave energy conversion array occurred in 2007 off Portugal. It was 5 of these devices, and these are, I wanted to give you an idea that these are like not small. These are huge things. This is called a pelamis, and pelamis is the genus of sea snake, and they go like this in the water, and all of this kinetic energy. So I thought it was a very clever name. So it's called pelamis, and they were installed off of Portugal, and unfortunately, just a couple of months ago, they shut them down, and the project is not going to continue. There just wasn't enough electrons moving to do more than partially do a little coastal village. So it didn't turn out as good as anyone had hoped. But this one, give you an idea of how big they are. This is called the Oyster, and it has to sit so that when the top of it opens, it's up above the waves, so it only sits in about 20, 30 feet of water. But it's called the Oyster, and it does this. And there's 3 of them up off Alaska that do this from wave energy, and it actually pumps water onto shore that turns a turbine that makes electrons, that turns the heater on in the school in Yucatan, Alaska during the wintertime. But these things are really kind of in the design stage still and in the testing stage. So what isn't in the design stage or testing stage that's renewable energy that could be on the outlook for California? Well, windmills. Just think of Holland. You know, the idea about windmills and using the wind for power is hundreds of years old. And this is a floating wind turbine, and you can see that it's pretty darn big, and it's really pretty heavy, and it is already at a scale that can plug into the national grid and help turn my lights on. On the west coast of continents, the continental shelf falls off pretty quickly. It's not like a volcanic island of Hawaii, but it's pretty quick. If you go 7 miles or 20 miles or 35 miles off the California coast, if you go 35 miles, you are in somewhere between 3,000 and 4,000 feet of water. If you go 35 miles off the Atlantic coast, you're in about 120 feet of water. If you go 7 miles off the Gulf of Mexico, you're in 35 feet of water still. In California, 7 miles offshore, you're in 1,500 feet of water because our continental shelf falls off pretty quickly. So in order to have wind turbines in the ocean off our shore, they need to be able to float. And this is now a proven technology, and this is one of the floaters. To give you an idea about Europe, Europe started this modern offshore wind turbine installations in 1991. It was Denmark that did that. It was called the Rev Horn because there was some piece of land that was close to the Rev Horn. They are now decommissioning the Rev Horn, Denmark, and putting new, more efficient blades and it's called a nacelle where you have the turbines and stuff on the top of these. But 1991. And here's the numbers. These numbers increase so fast, about every 3 or 6 months. This is what I could find this week on the internet. More than 126 wind installations or arrays. They're off Cyprus, they're off Japan, they're off Italy. Most of them actually are in the North Sea off Northern Europe. But there are 126 arrays of installations. There's more than 3,000 actual wind turbines in the ocean, and there are none on the US OCS. So this is just a map to show you where they are. Germany is just Germany. They power 10% of their nation now, and for the first time this year in 2016, combined with solar, combined with biofuels, and combined with on-land windmills and offshore windmills, They actually burn less coal to fire the nation. The other ones, the coal is less than 50%, and the other renewable energy is more than 50% for the first time. Germany has an incredible goal, like we're going to have 100% national on renewable by 2060 or something like that. It's amazing. And Britain, wow, England has just got a lot. They've got 12% of their national supported by this energy, and they're just going to go for more. So what's on the horizon for renewable energy, for California citizens? Okay, renewable energy leasing and installation of wind turbines is your outlook. That's what the outlook is. This is Trident Winds. I don't know if anybody's heard of Trident Winds, but they've made an application for a commercial lease, and it's right below the marine sanctuary. By the way, my agency has no jurisdiction in a marine sanctuary, and there's nothing set up in a marine sanctuary for renewable energy or energy extraction of any kind. So not within the Monterey Bay National Marine Sanctuary. Here's where it is. Here's California, so here it is. We're down here somewhere. Right here. Trident Winds is the name of the company. They have a website. If you want to go to the website, they want to put in around 100, maybe a few more floating wind turbines, and they want to do it as soon as they can get the permits. Now, you know, I work for the government. I know about paperwork. There's a lot of paperwork. But, okay, they are well-funded, by the way, which is really important. Venture capital is not the name of the game if you're trying to put in 100 plus. So they're well-funded. They have a website, and this is happening now. This Cal Wave Energy test site, they haven't really applied to us for any of this. They're thinking about a couple of sites to test some stuff. It seems like there is a great deal of discussion and no actual movement forward. So will this ever come to be? I'm not sure. Certainly it would be testing only. It wouldn't be for major grid input at all. So one of the things that I started thinking about, I don't know, 5 years maybe now, is what kind of research do I need to start thinking about to try to get done for renewable energy before people start making decisions to install windmills off the California coast. So I talked to a lot of fishermen. My father was a commercial fisherman. I like talking to fishermen. You know, I grew up in a fishing family. That's what I do with my oh so precious spare time. And one of the things that all of these devices, whether they're wave energy converters or a wind turbine array or some kind of a wave motion thing or a floating wind turbine, is that they got to move the electrons to shore, and you have to move it through a power transmission cable, and a big one. This is the issue. This is Nikola Tesla. And Nikola Tesla found out about electromagnetic fields generated when you push electrons through a copper wire. And this is the issue because many marine animals, well, issue for me anyway, many marine animals are sensitive to electromagnetic fields. Talk sharks, stingrays. Sharks use it to hunt, use EMF and use other electronic fields to hunt. So this is the issue that I decided I was going to investigate and do science for, because power transmission cables emit EMF, and we're going to have, if we so choose, to go ahead with offshore renewable energy in the form of wind turbines. We're going to have power cables coming to shore. Now, there's not going to be 100 power cables coming to shore. There's going to be 3. These are not, I'm not talking about data cables, so I'm not talking about telecommunication cables. I'm not talking about my internet. I'm not talking about the internet sharing with Hawaii or Japan. I am talking about power transmission cables, not data cables. Data cables don't emit EMF. You have to push a lot of electrons through copper wires to do that. So the question that I decided to look into was, does EMF affect marine fish and invertebrates? So we have some more discoveries. This time we used a different sub because the delta was no more. This is called the dual deep worker. We call it the deep worker. And same boat. Actually, the boat is registered in Seattle, but the captain keeps it up in Alaska. So it comes down from Alaska. This sub is Canadian. So the boat stops by and picks up the sub, and the sub guy's from Vancouver. And then they come on down, and this is the little sub. And it's time for me to show video 2. This is a little more professional, but it was about 10 years after the other video. This is on our website, by the way, BOEM.gov. I'm behind the camera. So on the Delta, the safety check took about 15 minutes. On this sub, it takes about 3 hours. So we go underwater and we count fish, just like we've always done. This is the scary part on any of this research. That's Donna Schrader. She works for me. Okay, that's enough. So, are the animals attracted or repulsed by electromagnetic fields? This was a project of opportunity, because here are the platforms off of Santa Barbara. These are the Exxon platforms. Because of air quality issues, these platforms are powered by giant electric extension cords. In other words, power transmission cables. And not all of these cables are actually installed. There's one cable here. They were all made by the same manufacturer in the same run and installed in the same year. That was important. And there's 4 cables. One of them has been cut off at both ends, so we know that cable's dead because it's not plugged into anything. And we have these other cables, A cable, B cable, C1 and C cable. We use the sub in deep water to run transects and count macroinvertebrates, so like starfishes or sea stars, depending on how old you are, what you call them, and crabs and things like that, and fishes. We ran the transects on that. And in shallow water, we let the scuba divers do it. And this is a power cable, and this is seaweed growing on the power cable. And that's important because sharks come in and lay their eggs, their mermaid purses, the swell sharks and the cat sharks, on those seaweeds. Okay, so just want to tell you, one of the things that we discovered was that EMF doesn't extend far from source. Now you'd think, well, didn't everybody know that? Actually, nobody knew that. Nobody in the world had actually done what we did and measured the EMF on the cable. This is the mechanical arm from the sub. This little white thing, it's about that big. It's round. It's the actual EMF meter, and we had it certified back east and calibrated by MIT and the whole thing. And this, the guys from British Columbia, the guys that run the sub, their little boys play field hockey. So they took field hockey balls and field hockey sticks from their 12 and 14-year-old boys, and they made these measuring devices for us. So, gotta love it. So if you line both of the hockey balls, which you can actually see underwater, and you line them up both on the cable, you're pretty much at a 90-degree angle, or a straight line, shall we say, a straight line to the cable. And then you mark the cable. This is a meter, this is a half a meter, this is a quarter meter, and this is right on top. You can actually measure the EMF, and that's what we did. And you know, I don't want to confuse you with numbers, but we measured the mean EMF readings in microteslas, and using scuba, this is what we found, and using the submersible, this is what we found. And I guess what's important is at 1 meter, you have dropped orders of magnitude. So it really, the cone, if you want to call, I don't know if you call it cone, the sphere of electromagnetic fields really doesn't extend very far away from the cable. And that's how we did it. Another thing I want to point out is there's always something living around the cable. Over on the mud and sand, of course there's things living on the mud and sand, but there are always things at or on the cable. These are Metridia anemones that have gotten very disturbed by the submarine engine when we do our transect, and then we get situated so we can take our readings. Okay, this is a very sophisticated mathematical way to look at your data, but it is, don't tell anybody, it's so easy to read, and I'll teach you how to read this. Anybody can read this. First, let's look over here. What are the red things, the red symbols? Well, those are all the hot cables, the energized cables. Oh, and by the way, we took thermometers. The cables aren't hot. Everybody wanted to know, are they hot? Well, only in a sense that they pump electrons, but they're not warm. We took a thermometer, we stuck it on the cable. No, no, no. Okay, so we've got energized cables are red, unenergized cables are blue, and the X's are the natural habitat. So you pump it all into, you put all your data in the computer and you pump it all in, and you ask it to show you similarities and differences. Well, the blue ones are not off by themselves, and the red ones are not off by themselves. They're all together. And the natural habitat, these are kind of off by themselves. And here's another one, but you always get red and blue together. And these numbers just mean transect, and that has to do with depth. So you can just kind of ignore that. But look, it's not about whether the cable is energized or not energized. It's about whether or not it's got any habitat that sticks up above the bottom like a cable at all, or if it's just mud and sand. Now, the mud and sand is very important. That's where you get your flounder, your halibut, and fishes like that. But what this shows is that it's not about the cables or whether or not they are energized or unenergized. Here's the one for invertebrates. This one is a little more complicated, but you can read it the same way. Where are the things kind of coming together and coming out from other things, separating out from other things? Well, this one is the same thing. Even where you have reds, because this has to do with depth, you have blue. So it's really, and look at this, it's not about separating cables, one being energized and one being unenergized. And then this is natural habitat. So invertebrates don't care either. Okay, so that was the first major discovery that we did, and we're getting ready to publish it right now. As a matter of fact, the scuba part, we're putting in the bulletin of the Southern California Academy of Sciences. Julie would like me to say that. Okay, so we did another study, and the report from the first one and the paper from the first one should be out in like 3 months or so, the scientific peer-reviewed paper. Well, we have a real different boat on this one. It's really small, and we've got scuba divers who froze themselves to death, and we're looking at, this is a crab trap. This is a Dungeness crab trap. You know, Dungeness was on the menu. Mike and Julie and Ed took myself and my husband out to dinner tonight, and Dungeness crab was on the menu. Because this is a Dungeness crab fisherman, this is a power cable, this is his boat, and this is what's important to me, of course. So this is what it's about. And I was actually doing some sub work, and I was sitting out there, and fishermen are very concerned, as well they should be, and my father would be too, would he be alive. Crab fishermen, you know, crabs crawl on the bottom. They don't swim up in the water column like fishes. So they crawl across the bottom and they crawl into their traps. And they were very concerned that a power cable would present an electric fence on the seafloor, and the crabs wouldn't walk back and forth across this electric fence. It's kind of like my dog. Should I put an electric fence in my backyard so it will stay out of the garden and stop eating my vegetables? So they were really concerned that an electric fence and crabs, and they weren't going to be able to fish, and they weren't going to be able to sustain their life. And this was a really important, and I was out on a sub cruise, and I thought, well, we could test that. So this should look very familiar. This is the Exxon power cables. These are the cables to shore. We've got hot ones, we've got cold ones. This is a 35 kV alternating current power cable, and it's 24/7 full charge. If the platform can't use it, they bleed it off. So there's no change in capacity or in current level for these. And we went up to Puget Sound because that's where most of the Dungeness crab fishermen, or at least a lot of them. So we got together with rockfish fishermen down here in Santa Barbara Channel, and we got together with Dungeness crab fishermen up in the Puget Sound, and this is where it's really cold water between Canada and the United States. Yeah, the water's cold. But they move electricity around these islands in Puget Sound using power transmission cables. It comes from the Orcus Power and Light Company, mainly. So I thought, okay, we could test this. And this is how we could do it. We could give crabs a choice and actually get crabs to decide if they will cross a power cable in response to a baited commercial fishing trap. So this is the layout. You can call it a unit, so let's call it a unit. This is one unit, or you could call it a run. I used to call it a run, so let's call it one run. All right, here's the power cable. This happens to be a white line on the street, but here's the power cable. Here's the crab introduction chamber, and here's a baited trap choice, and there's a baited trap choice. If they decide to go in here, they have to walk over this power cable. We lined the inside, the ceiling and the sides of these so that they couldn't crawl up and crawl across the ceiling and get away from the power cable. If they're going to go in here, they're going to walk across an exposed power cable. And then we looked at pieces of power cables that were maybe 4 or 5 inches buried to see if there was kind of a big difference there. Okay, so we have 12 of these units. They are 16 feet long. They're pretty heavy. They're made out of the same materials that commercial fishermen, because we consulted with commercial fishermen, what commercial fishermen use. We have 12 units. We used 3 replicates of 4 test conditions. And this was a good idea. This wasn't necessarily my idea at all. This was Mary Nishimoto's idea at UC Santa Barbara, that we put some of them so that the crabs, if they're going to walk across the line, they have to move to the west. If they're going to walk across the line, they have to move to the east. And we have 3 sets of these 4 test conditions. So we had 12 units. Some of them are over on the mud, some of them are on the cable, some of them go east, some of them to the east, some of them to the west. So this is the crab experimental trials in the field. This is a pretty obvious power cable. Just before they get into the trap, we actually designed the entrance to the trap so they actually sits right on top of the cable, so they have to walk right over it. So anyway, power cable, crab introduction chamber, baited trap, And here's a power cable. This is in Puget Sound. This is Dungeness crab, Puget Sound. Here's the cable. Had to walk across this cable to get into the trap. So what are the results? Well, we tested over 500 rock crabs in the Santa Barbara Channel. And we tested, nearly 300 crabs up in Puget Sound. It was a lot of work. And what we found out is that the more and more crabs you test, the more and more it was like the flip of a coin. If you flip a coin, you have to flip a coin thousands of times to actually get 50% heads and 50% tails if you ever actually get there. So this is what we discovered, is that they'll cross the cable. There's actually no difference between crossing and not crossing the cable, so it was the crab's choice. But this is what we found, that when you actually look at all over 500 crabs studies in the Santa Barbara Channel, and you look at the prevailing currents of which way the current's going, and you look at all of the nearly 300 crabs in Puget Sound, and you look at which way the current's going, that's what the crabs want to do. They want to go into the current because they're smelling the bait, and they just want to eat. So California law makes it possible to consider offshore renewable energy. What will the state and its citizens decide? I've said a lot during this talk, and I've used the word we. Well, don't ever believe that anybody who ever stands up here does it by themselves, because we don't. I have a great crew of people I work with, and literally, probably over the years, hundreds of grad students and many, many, many principal investigators from academia. Cal State University, University of California, Occidental College, and community colleges, and Cal Poly. Just a really great group of people to work with. And that's my contact information. And let's get into talking about this.
Questions for Dr. Bowe?
Yes?
Yeah, I had a quick specific technical question and then a more general question. Were those power cables all operating at power line frequencies, like 60 hertz or three-phase?
Oh, sure. Yeah, 60 hertz.
It wasn't high frequency?
No.
Do you have in your department, have a wish list of projects and things that you're looking forward to presenting to AltaSea to have people bid on or think about or do?
I would love to have AltaSea's interests and come, and I'll go to them or they can come to me. I know Dan Pondella, who's a big part of AltaSea, very, very well. As a matter of fact, the paper that was published in the Proceedings of National Academy of Science, I'm an author, he's an author. Jeremy Clace, who was the first author, Milton Love from UCSB is an author. Jeremy Clace, he was an actual postdoc at Occidental during the time that he did all the math, because there was a lot of math and modeling involved. And I would love to have that happen. We do have budgets for scientific research, and along about every October, we actually open it up to the public and AltaSea and any other federal agency and people, and we ask them for their ideas. And we take those ideas in, we look at those ideas, we figure out how to go about this. Sometimes getting the money for the actual research is a little harder. I'm talking about paperwork, than actually maybe starting the research. But yes, I think that would be a wonderful way to join in with the community. Now, because the Bureau of Ocean Energy Management, BOEM, is a regulatory agency, the science that we fund and the science that we do has to be tied to our mission. It can't be like great, terrific medical research to look at Zika virus or cancer or Ebola, because that's not tied to our mission. So it has to be tied to something about offshore energy possibilities, or I got Sea Grant to actually include offshore urban, or I called it something like urban energy, urban ocean energy, for the first time in their grant proposal announcements. I said, you know, Los Angeles, we're talking about Los Angeles. We really should be talking about where we're going to get our energy. So they included that in 2015, but it was the first time that they included that subject as a way for students and others to send in proposals and perhaps get a grant to do work. So I'd love to work with AltaSea and anybody. Oh, there's got to be ideas galore in this room about what to do in the ocean. Yeah, I'll never run out of ideas. I don't know who was first.
Yes, on the turbine farms, that's what we're used to calling them here. We have them on land, but have you done risk management about adverse effects? If there's a tsunami or a rogue wave, how will that be taken care of? And on the ones that are floating, have you done any studies of the effect on marine life there?
Well, as in most things in life, you've got to know the negative with the positive, and it's about trade-offs. These floating windmills, wind farms, were also tested in the Bay of Biscay off of Portugal. So Bay of Biscay is rather infamous for their horrible storms. So I don't think we have to necessarily worry about weather storms. About tsunamis and things like that, well, the Japanese, they have them off of Japan, and the Japanese have done quite a bit of work on them. They're using floating devices up off of Scotland for actual grid connection. I won't say that there isn't a whole lot more to do. I can think of a lot of things to do. And one of the things that that maybe some of you thought about, but not everybody, is birds. Birds and bats. Birds, bats, and butterflies, actually. The 3 Bs. And there are things that you can do that will mitigate. It's called cut-in speed. So you can keep your speed at the blade tips really low. So you can do a lot to mitigate and really decrease environmental impacts, but there's never going to be none. Will they act like fish attracting devices in artificial reefs? Oh, probably, given time and given how far underwater they extend. But, you know, they're not the same as a platform in terms of how much stuff is underneath the water, but they're still huge, a lot of surface area under the water. But no, there's going to be, so to answer your question, yes, the risk modeling has been done. And certainly it has to be done by the company. And certainly the company has to take absolute ownership of the liability risk. The Trident winds, they want to put them 35 miles offshore. You know, does that mean they'll never end up with some of them breaking free and going away? I kind of doubt that, because they're going to be cabled and anchored to the bottom. There'll be 4 cables per unit. And this is very analogous to the engineering that's been used for deep water offshore platforms in the Gulf of Mexico. They don't actually when you get really deep in the Gulf of Mexico, they don't extend from the sea surface to the seafloor. They're cabled and anchored to the ground. So the engineering is proofed. I mean, they get hurricanes in the Gulf, so the engineering's pretty good. Next.
Yes, I was curious about the cable itself. I was wondering if the cable was shielded, like acting like a Faraday cage. You know?
Oh yeah, no, it's fully shielded, because you'd get electrical leakage if you didn't have it shielded. And we tested these runs, these units that we used. We tested them to make sure that they weren't going to negate and be a Faraday cage. But the cables are not leaking electricity, and they're fully shielded. They're actually encased in epoxy, and then they're wound, shielded with steel. That's why they kind of look a little ribbony. I don't know if you noticed it in any of the photographs. So that's a real good question, but it's not an issue for us in our experiments and our field work. Did you have a follow-up question first? No? So, Pat.
I did with a follow-up with, I scuba dived off to Santa Rosa, and that's a decommissioned rig, and it was Chevron, and.
Where?
Santa Rosa Island off the coast here. It's part of the Anacapa, or the Channel Island.
Well, you maybe dove on a platform that's still standing.
Well, they said it was decommissioned, that's why we're allowed to dive, and you had to get a permit to dive for the day, and there's scuba boats that go out.
What was the name of the boat?
That I don't know. But maybe it was through, I'm an Air Force widow, so maybe it was through the military that we did it.
Well, there's no petroleum platform that has been decommissioned off California. There are 4 in state waters that have been removed. They were called the 4 H's, Heidi, Hilda, somebody and somebody. They all have names. Sorry, don't know Hilda very well. But they were taken out in 1994 and there's nothing left. So, I don't know. Drop me an email. I'll figure it out.
Something with the military, but, well, my question was that, because they had Chevron written, you could see it on the bottom from the water looking up.
You sure this wasn't off Pensacola, Florida, where I dove on a Chevron platform?
I did live in Florida in the homestead, and we would do a lot of things there, but no.
No. Okay.
I was just, they were saying that the oil platforms that they have here, they won't make them artificial reefs because the oil company won't pay for it and the state won't pay for it. So do you know anything?
To make an artificial reef?
Just divers talking amongst themselves.
All right, 2010 law. It's called AB 2503. It was a law that California passed it was the last law that Arnold Schwarzenegger signed. I was in the sub, in the water, and I got this garbled message from the guy running the Zodiac. Donna told me to tell you that 25, scratch, got signed. And I knew what it meant, but anyway. That law says that if the citizens of California allow something to be reefed, cut off 85 feet below the sea surface, that the company has to give half the money, or maybe 60% of the money, that it would have cost them to totally remove that platform. They have to give it to the state. If it costs $1 billion, or 2 or 3, to take out Harmony, the one that's 1,200 feet deep, and by the way, I'm not even certain that the technology has been developed to take, certainly you can't take it out in one piece. It's too darn heavy pulling it out of the water. So I have to take it out in pieces if they take it out at all. Anyway, that's probably going to cost $10 billion. So the state Fish and Wildlife and the State Lands Commission and the Ocean Protection Council get half of what the savings are. And that's what the law says. And it's not the industry, it's not the company that gets to do the model to figure out how much it's going to cost. No, that wouldn't be right. So it's a third party. I think it's like Stanford will figure out what that is. There's a group at Stanford called Lumina, and 2009 I worked with them on an economics model. So anyway, I'm very curious about where you dove, but I don't know. Pat?
The other night on PBS, I happened to catch this documentary on this wind farm, proposed wind farm off Cape Cod in Massachusetts.
Oh, Cape Wind?
Cape Wind.
Oh, it's never happened, yeah.
I was going to say what happened to that.
Right. Well, Cape Wind, it's interesting. You know, you learn from your mistakes, and you learn about the fact that this was the first wind farm proposed off of the United States. It was on the Nantucket Shoals. I don't know, I think at low tide there's about 6-8 feet of water over Nantucket Shoals. It was a very popular place to yacht and sail. It wasn't really fisheries, not in that kind of water, in that off New England. But it ran into a real backlash from citizens and from people like John Kennedy Jr. and the Koch brothers up there who own homes and who didn't want to see it. They didn't want to see it on their horizon. They didn't want to see it in their view shed, and they didn't want to sail through it. They didn't want to sail around it. I mean, they didn't want to have to sail through it, and they didn't want to see it. And view shed is a very, very important thing for the citizens of California. You want to go sit on the beach on a Friday night and look at the sunset and eat tuna fish sandwiches like my husband and I do, or did a lot of the times? Do you want to be looking at windmills? Okay, so Trident Winds is 35 miles offshore. I don't care if you're in a 10-story tall building on the beach in Morro Bay, you're not going to see them. You're not going to see the windmills. If it's 7 miles from shore, yeah, you might see them, especially at night. They're going to have red blinking lights on them so the airplanes don't hit them. So, yeah, it's very, very important, and that's part of this trade-off I was talking about. Where are you going to put them? How are you going to do? And what are you going to accept or deny? We were talking about the new Tesla today in the car. Did anybody see the new Tesla? Raise your hands. Did anybody see the new Tesla yesterday? Ooh, I like the red one. But I got to plug it in. So I got to be able to charge it, and I got to get my electrons from somewhere. And it's up to us together to decide where are we going to get that. Are we going to get it from coal? Are we going to get it from fuel oil? Are we going to get it from gasoline? Are we going to get it from wind? Are we going to get it from wave? These are all things that we're going to have to decide because they're all on our outlook. They're all on our horizon as California citizens.
How about one more question? Why don't we get somebody right in the very back? I know you've been waiting.
Well, I had two.
Okay, two.
What you showed of the cables, hot and cold, with the X's for fish life, I thought it looked like fish life stayed away from the cables.
No, the X's were the mud sand bottom. And the red and blue dots and triangles and squares, little squares, the red ones were the energized cable and the blue ones were the unenergized cable because they've been cut. And we also can measure EMF, so maybe they're not using a cable at that time. So the reds and the blues, in other words, all the cables, whether they're energized or unenergized, hot or cold, the fishes are the same. Doesn't matter if it's a hot or cold cable. The numbers of fishes and the species of fishes, they're the same numbers. They're related. The numbers are about the same. They all group together. So the fishes or the like really low numbers of fishes that you might have thought would occur with a non-energized cable, they would have been off by themselves. The blue would have been off by themselves, and the red would have been off by themselves. And then you could have said, there's something about the cables that make it really different. But you can't say that, because the red and the blue, they're all together. They're all grouped together. What grouped separately was all the X's, and all the X's are all the transects that we did over on the mud and the sand, away from the cables. So that's what the separation was. The natural sand, mud, and the cables, but there wasn't any difference between the cables. So it's not about whether it's a hot or cold cable, it's about whether it's mud or sand or a cable habitat.
Dr. Bull, thank you so much.
You're welcome. Thank you.